in the last 10 or 11 lectures, we have discussed about the fundamentals of compressible flow, which is quite important for analyzing the various aspects in propulsive devices, right. When I say propulsive devices, it will be either the gas turbine engine or the rocket engines, right, or any other, even the internal combustion engines and other thing. And there we need to analyze each components. For that we need to invoke the what you call compressible flow. And if you recall, we started with the definition of the compressible flow, how it is different from the incompressible flow. Then we moved into the governing equations like conservation of mass, momentum, energy, and then equation of state. And then we looked at how to handle the what we call quasi one dimensional flow, and then we derive relationship between the area ratio and Mach number, which can be useful for designing nozzle, diffuser and other components as well. Then we moved into the normal and oblique shock, and we derived the expressions for various pressure ratio across the shocks, and then we learned that how to use those expressions for analyzing the flow with shock. And then we moved into another one dimensional treatments with heat additions, right, which will be mimicking the combustion process, and how does the properties will be changing with the heat additions. And then we moved into a again one dimensional flow with the frictional effect, without really invoking the concept of boundary layer. And although these analyses are meant for one dimensional, but similar feature can be for multidimensional cases, but we will be restricting to the one dimensional flow for design purposes of the which will be simple and easier to handle. And today we will be looking at the fundamentals of combustion, because the combustion plays a very important role, that most of the power plant for the propulsive devices, right, relied mostly on the fuel or the chemical fuels, right, for its energy. And as I had discussed in the what you call earlier classes, in the introductory lectures, that barring few devices, mostly we use the combustion or the burning of fossil fuel and also the other fuels in rocket engines, like for powering our aircraft or the rocket engines, right. So, therefore, one can say that combustor is the heart of propulsive device. So, it is very important to understand the fundamentals of combustion. So, if you look at we will first discuss rudimentaries of the combustion, and if you know you might be aware the combustion is as old as civilization, right. And we know historically that people believe that the men were living earlier in jungles like other animals, and they started discovering the fire, right. And therefore, the fire is one of the greatest discovery of the man, right. And then they use it, control it, and then therefore, they could manage to develop a lot of science and technology that we see. That means, man's subsequent mastery over the fire has made all the development in science and technology that we enjoy today. But however, we are enjoying too much, and we are also spoiling the nature, the mother nature, to that extent life survival is at stake at this moment. And that is of course due to the greedy nature of human being, right. So, of course, our ancestors were aware of the very fact that fire is the genesis of life, and they were professing a science and technology which were very benign to the nature's other activities. But today we are at different realm of science and technology. So, it is very important to look at that aspect, not only for the propulsive devices, for others as well. And you will find that our scriptures are filled with a lot of prayers for fire, and also they were knowing how to use that for the sustenance of life, human life in the earth, without really spoiling the nature, which is very important. So, even today the knowledge of combustion is very relevant, because of what? Because of the scarcity of fossil fuel and also the stringent emission regulations, because we are emitting too much of pollutants, particularly from burning of fuels and also from other sources. As I told, that the very life on this earth is in trouble at this moment. So, therefore, it is very important to understand the combustion aspects, and more in detail, right. And if you want to really understand this combustion, we need to go to the fundamentals and talk about it and learn it. So, that means I can conclude that combustion is an exotic subject which will remain as an important area of knowledge as long as human civilization exists in the globe. Because if you look at the fossil fuel may not be there for maybe another 100 years, but however, we cannot rely on nuclear, because of greediness of human being, and also it is quite dangerous to handle nuclear, power plants and other things. So, we need to go back to the nature to pray for or to ask for the fuel, which will be basically biomass and solar and other things. So, for that combustion is also important, and we need to understand that. Question arises whether we can have some eco-friendly propellant for rocket engines or this thing, so that we can do that. It is important to look at, because we can have that, but you need to be innovative to do that. So, question arises, what do you mean by combustion? Can anybody tell me? Because we use combustion in everyday life. As I told, always saying that particularly Indians, whenever a child will birth, we will burn a lamp. When man will die, we will incinerate it, right. We will again use the combustion. From the birth till the end, combustion is a part and parcel of human life, at least in India at this moment, even earlier days, right. So, what do you mean by combustion? We may talk like that, but what do you mean? For a layman, it is like setting a fire to a fuel, right. Is it good enough to say that, look, combustion is nothing but setting a fire to a fuel? Certainly no. That means what is happening? When I say fuel, there will be oxidizer, right. Question arises, what do you mean by fuel and what do you mean by oxidizer? And when fuel and oxidizer are reacting, then naturally there will be some kind of heat and light being produced, right. Of course, light need not to be produced all the time, but heat must be produced. Heat must be produced, otherwise, and whenever the heat is being produced during these chemical reactions, then we call it as exothermic reactions. Is it all the reaction, whatever taking place during a combustion will be exothermic? Certainly no, but overall effect will be the exothermic. So, therefore, we can call it as a combustion as a self-sustained chemical process involving several reactions, during which heat is liberated due to overall exothermic chemical reactions, right. So, there are several examples of these combustion devices, starting from the LPG burners, what we use in our home for cooking food, right. And furnace, candle flame, internal combustion engines, gas turbine engines, rocket engines, so on and so forth. There are several applications. As you go along I will talk about, but we will be restricting our discussion in this course to the gas turbine engines and rocket engines only, but however, I will try to give a overall pictures about the scope or the magnanimity of the combustion so far application is concerned, right. Now, question arises, what are the essential conditions for the combustion to take place? When I talk about combustion, that means there will be fuel, there will be also oxidizer, and when the fuel and oxidizer are there, they must be mixed somehow, right. For example, if I take this room and it is having some air always there, right. Air means it will be containing oxygen, but if suppose I am having a gas, let us say LPG gas, LPG gas we use for cooking for in a burner. If I just allow the LPG gas to be there in this room and mix, then is it combustion will take place, right? It won't. That means you need to what? Ignite it. But even if I am igniting it, igniting means basically initiating it, right? Then is it possible it will ignite and make it self sustained, because as we have looked at that combustion is basically self sustained chemical reactions, which must be exothermic in nature overall wise, right. It cannot be self sustained unless it is exothermic, because where heat will come to be make it self sustained, right. Now, what else? It must be in the right fuel air ratios, right. That means, to summarize, there must be fuel and oxidizer must be there, need not to be only the oxygen, right. Oxidizer can be any other things, right, and the fuel air ratio must be in the right proportion dictated by flammability limit. What do you mean by this flammability limit? As I go along I will be talking about, but we will not be getting into it. And ignition energy. The question arises, what will be the amount of ignition energy, and all those things we need to look at, right. And if I want to look at this combustion, what are the things it should have? It should have a fuel and oxidizer, and you should have ignition energy, right. I always feel that this combustion is similar to of a human life, right. How it is, you people can think of. Can anybody tell me how I can take a similitude from a life and say that combustion? I will tell you, for example, a person has taken bath. That means it is started life and then it will continue till death. Similarly, if we are having a fuel, it has to be burned till the fuel is exhausted out, right? Yes or no, right? And if you do not have a surrounding, can you sustain a food? Suppose you do not have a food, how will you do? And you need to have initiator or to the life, and your father, mothers are initiators, right? Even society to help you to learn the thing. So, therefore, one can think about combustion is nothing but a part and parcel of life, and therefore, our ancestors were always appreciating the fire, the energy which comes from everywhere. So, now we look at what are the constituents of combustion. That means is basically what are the subjects you need to have a command over the combustion process, subject. That means it is, if you look at, you need to learn about thermodynamics, right, and as we have already discussed for while discussing this is the thermodynamics, and you need to know the chemical kinetics, because it is the involving chemistry. So, you need to know the chemical kinetics, and not only that, but you need to look at the heat and mass transfer, because without heat being transferred you cannot have a combustion. So, also the mass transfer, that means mass has to move and mix together, then only. So, you need to have a heat and mass transfer, and also the fluid dynamics, which we have already discussed extensively. So, therefore, combustion is basically a multidisciplinary subject. To get a command over the combustion, you need to learn other subject very well, and you will have to devote a lot of time and perseverance, then only you can be a master in combustion, otherwise no, right. So, it is a multidisciplinary, and engineering is basically a multidisciplinary as well, right. So, therefore, it is important to be look at combustion, and it is the, as I told, it is the power house of any vehicle like aircraft or a what you call the rocket engine. That means, it is the heart, combustor is the heart of the engine, and engine is the heart of the vehicle. So, it is the heart of the vehicle, you can say that. So, what are the applications? If you look at, there are several applications, I will just jot down some of them. One is the power plant. If you look at this picture I have shown, mostly we use the pulverized coal, and of course, nowadays the gas being used to generate power, and there will be of course, the transport. If you look at transport, there is the locomotives like on the land and the sea or the in the air, there is the rocket engines and then gas turbine engines. These are the applications, broadly it can be classified. And chemical industry, there are several chemical industries which rely on these combustion processes, starting from your refinery to the what you call the fertilizers, cement and any other chemical producing devices, blast furnaces, metallurgy. There are several applications. If you look at club, all those things as a chemical industries, because all requires chemicals. So, and of course, the domestic applications, we know that, keep in mind that all these devices are sources of air pollution and also the water pollutions. That means, we need to be carefully use the energy for our life without spoiling the nature which support us for our life. That is a very important part, what our ancestors were talking about, not going against the nature nor winning over the nature, rather be a part of nature, right. And that is the philosophy we need to adopt in the modern life to save our earth from the onslaught of this blatant use of science and technology in human life. So, that does not mean that we should not use, we should use it sparingly, we should use in a sustainable manner, such that we can develop a good earth for our next generation. So, now coming back to that, as you look at this combustion, like it is having a subject thermodynamic, fluid dynamic, heat and mass transfer and kinetic energy. I have just put this thing applications. If you look at, there are several applications. If you remember that I had talked about earlier about Rankle engine, which is I like it. Of course, it is not being used nowadays, but I feel it will be one day will be used, maybe with the what you call contribution from people like young people like you. And it is a very good for the, because it is quite compact, it can be used for the aircraft applications. And of course, the IC engine, which is what you call being used from the time of Wright brothers till today, it is being used profusely for driving an aircraft, particularly small aircrafts, which we will not be discussing, but however, it is a very important engine concept. And like material synthesis and other things are being used, and incinerator, as I told that these our ancestors were knowing how to incinerate the dead bodies. It is a very nice way of doing it, and we need to work for that to make it more benignly environmental benign, and boiler, which is the basically we get power, and I have shown a diagram over here, and furnaces is being used. There are several kinds of furnace, blast furnace, coke oven furnace, there are several like glass melting furnaces, there are several of them, and which is used in industries, and that uses combustion. Of course, the gas turbine engine, which is being used for our aircraft propulsion, and also the power plants generating power, rocket engine, which we will be discussing both the gas turbine engine and rocket engines to propel an air what you call rocket, the power generations, and there is a very interesting thing recent time, there is a micro combustors, which is having a lot of applications in what you call micro air vehicles kind of things, right. And there is a new engine which is coming up, is pulse detonation engine, which can be used for aero application as well. So, and of course, as I told, this is a fire, which is the genesis of our life, and if you look at fire, everywhere is there. And so, therefore, these are the all application one can think of, because when I am talking about what you call combustion applied to the gas turbine and rocket engines, but we need to have a broader view. That is why I put these things before you, and question arises now, what do you mean by a fuel? Because we need to use fuel, we must know what do you mean by a fuel. Can anybody tell me?
So fuel is the combination of hydrocarbons that release the heat on breaking the bonds between them.
Yeah, but if you look at, there are several fuel which are not hydrocarbon, right. Can you not call it as a fuel? But I want to define what do you mean by a fuel.
It's a chemical when
yes,
when oxidizes releases energy.
but I can ask, suppose there is a fuel, but can it be act as an oxidizer any time? Not possible, right. For example, like oxygen, we know oxygen, right, in the air. Can it be act as a fuel? No, no.
I say when it is.
But it is, actually it is. That means we need to define a term which will tell us whether it is a fuel or not, right. So, chemically a fuel is a substance which donates electron, right. That means what is happening during the chemical reactions? There will be breaking of bond and forming of bonds, right. And this breaking of bond, how does really occurs? Because of like exchange of electrons, right, at the level, right. Then only it can be broken, energy can be released, because what you are doing, whatever energy is there, you are trying to release it and use it for your purposes of that is the chemical. So, when I talk about these electrons, it can be donated, that means one electron can go from one molecule to the from the atom level to another, right, in a molecule, or it can be accepted, right. There can be two things. If donation, your one is moving, other we can come also in. It is like a go of the wall, It is like if it is a coin, head is there, tail will be there, that way. If light is there, then darkness is there. That way, if you are giving something, you can accept as well. So, then when you talk about this, how will quantify it? How will talk in terms of, can you say that okay, one electron is moving, the another electron can be accepted, 5 can be moved and other thing. So, for that we can define a term electronegativity. That means a fuel must have a lower electronegativity. This term electronegativity, which was given by Linus Pauling, right, who was a Nobel laureate, who talked about this electronegativity, which is basically a property of elements ability to donate or accept a electron, right. In other words, it is basically says that what is the extent of an electron in an atom, the electrons in the atom in a molecule can be attracted to itself or it can be repelled from it, right. That will be the electronegativity. That means if you talk about this electronegativity, right, when you are giving, then what will happen? This will be decreasing. So, that therefore, if you look at this potassium is having 0.8, right, electronegative. That means, it can donate lot of electron, right. It is having higher capability to donate the electron, like it is basically a donor, you know. So, as you go along with this label, that means is 0.08, the sodium, lithium, magnesium, beryllium, boron, you know, this electronegativity increases, and similarly the hydrogen, you know, and carbon, it is also increasing, right, order. If you look at oxygen over here, and this O is oxygen and F is for fluorine, right. What it indicates? That means oxygen is having higher electronegativity. What is the meaning of it? That means it will be accepting the electron, right, it will not be donating. So, if you look at what are the fuels in our case, the reactive fuels will be which one the reactive fuel among all these things, right. If I consider the oxygen as the oxidizer, which is having a higher electronegativity. So, which will be more reactive or most reactive fuel among this table whatever I have shown? Potassium, you know. And but however, it is quite reactive, we do not use it in our data, but all metals, even like, you know, these are metals can be used as a fuel, right. And we use carbon and hydrogen as one of, you told that, you know, hydrocarbons we use as a fuel because it is available. And if you look at the, if any of these can be fuel and this can be oxidizer as well, right, depending upon, you know, what it is electronegativity. So, if you look at, we can say that in the similar way that chemically an oxidized substance which accepts electron, right. And we will take an example where we can say that, you know, oxygen can be acted as a what? As a fuel, like for example, F2O3, right. If you look at fluorine as the largest capacity to accept electron, right, because it is having electronegativity of 4. So, it will be acting like an oxidizer, whereas the oxygen, which is a common, you know, known as an oxidizer, right, it is a fuel because it is having a lower electronegativity. So, therefore, when you talk about this, one has to know what is the electronegativity, then only one can talk about it. And let me tell you, there is a fluorine, although it is quite reactive in nature, but in free form it is not available in India, in the earth crust, although their percentage are more, that is the good boon for us, otherwise it could have been more problem, right, is not it, because it is a very higher oxygen. And if you look at that our air, see how nature is being made, air which contains a large amount of nitrogen, which is a inert gas, right. So, that is the beauty of the nature. So, do not you think that it is quite interesting that, you know, oxidizer which is commonly believed to be an oxide can be acted as a fuel, right. So, now let us classify these fuels and oxidizer based on the physical states. We can classify, like for example, gaseous fuel, liquid fuel and solid fuel based on physical states, right. And of course, the gaseous fuel is quite easy to handle, am I right or wrong? Is it easy to handle? Certainly no, because there can be a lot of leakage, and to store a gaseous fuel is quite difficult, and to carry from one place to another is quite difficult, gaseous fuel. But however, it will be very easy to burn a gaseous fuel, right, as compared to the liquid and solid. Why it is so? So, gaseous fuel, as I told that they are preferred over the liquid and solid fuels, right, and because it is easier to burn with higher efficiency. But do you agree with this point that it is easier to burn with a higher efficiency? Why not the liquid fuel and the solid fuel? That question must be bothering you as you go along, we may see sometime, and it is easier to control the emission, which is a greater concern at this moment than what it was maybe 100 years back, right. And gas handling system is less expensive. Do you agree with this statement? Right? Certainly no or yes. Some of you are saying true, right? Why? Because if I want to atomize a liquid, right, I will have to supply a large amount of pressure. If I want to use a solid like a bulk, let us say wood or something, I will have to pulverize it, and to transport the pulverized fuel is quite difficult, and how I will control it is also a difficult thing. That means, I need to feed certain amount of liquid and or the solid fuel, whereas the controlling will be easier in case of gaseous fuel, right. So, therefore, that is the reason what I can give, but if you are having difference of opinion, we can discuss it. Commonly used gaseous fuels are basically CNG, LPG, biogas, producer gas, coke oven gas, acetylene, methane, hydrogen, propane, and so on and so forth. There are several kinds of gases. You might be knowing this full form. CNG is compressed natural gas. There is a people are talking about PNG. IIT Kanpur will be having that PNG, that is piped natural gas. That means, you will get gas in your home through a pipe conduits, right. And LPG, the liquefied petroleum gas. Of course, biogas, you might be knowing it is being used in rural area from the cow dung and others animal dungs kind of things, or any other even what you call leaves you can get by fermentation process. And producer gas, you might be aware that producer gas can be obtained by thermochemical conversion from the biomass and other biomaterials, right. I think you might be aware, you will be surprised to know that most of the automobiles were being run using producer gas before the Second World War, right, producer gas. And coke oven gas, of course, from the your coke oven furnace, acetylene, methane, hydrogen and propane we do use. And let us look at types of gaseous fuel at oxidizer, what we can think of. Liquefied petroleum gas, we know that it is used in our what you call houses, domestic purposes, and also it can be used in industrial purposes. Air and oxidizer. Can anybody tell me what this liquid petroleum gas is? It a one gas, or it is a multi gas, or is a two gases are there? What are those things? LPG gas. LPG we use every day, without that cooking food will be difficult, at least in urban areas. Propane only? Certainly no, right. Propane is fine, but methane is not there. It is the propane and butane. And what is the percentage? We will be looking at it. Compressed natural gas, what are its constituents? We will look at it. Can be used in IC engine, like in Kanpur city. Few years back we were using kerosene, we were using diesel, and it was creating lot of soot. Nowadays we are using CNG, right, compressed natural gas, and as a result the soot level or the particulate level in the atmosphere has been reduced drastically, right. Therefore, it is being used in IC engine, furnace and several other places like producer gas. Again, the biomass can be used, even coal can be, from the coal one can get also the producer gas. People are talking about, gasification process as the better way of abating the emission level, right, from the power plant. So, IC engines and then boilers and furnace, like methane, propane, hydrogen, can be used in several applications, whatever you can use, it can be used, and particularly the hydrogen is a very, very good fuel, but unfortunately it is not available in nature, right. We need to convert these fossil fuels or other forms of fuel to hydrogen. That is a big challenge which has to be, because it is a good fuel and having a higher calorific value as well. So, biogas which is being used in engine and burners, we know this acetylene we use for gas welding, cuttings and other things. So, let us look at what are the constituents of 5 fuels I have shown here. You can see that LPG, which contains propane 70% and butane 30%. You keep in mind this is in percentage. Okay. All data is given in this table are in percentage. That is, I have given some typical number 70-30, right. 70 is propane and 30 is butane, but in several other places you may find 60-40, maybe 50-50. That means these will be varying from different well to well or from place to place. For example, if we are having Godavari basins where if you take this LPG gas or this thing, then it will be different than if I take in the Assam or some other place, right. So, therefore, it will be varying in other countries also it varies the percentage. There is nothing sacrosanct about this percentage, but what we must learn that it is having propane and butane. Keep in mind that it is liquid at what pressure? Is it atmospheric pressure or what pressure it will be liquid? Actually, in case of your cylinder it is a liquid. When you open that means at a higher pressure it is a liquid. When you open it, then it convert into gas and you get the gas. That is the beauty of liquefied petroleum. Otherwise, you will have to carrying will be very difficult, right. Okay. So, natural gas, if I look at that in this table, it is something around 90% of methane, 5% of ethane, right, and 5% of nitrogen. You may get several other composition, as I told, it depends on the where it is being taken, from which well it is being taken, but generally it contains methanes in a large proportion. Similarly, the producer gas, if you look at, it contains basically the CO. If you look at, CO is a fuel, am I right, and it contains also hydrogen, and rest of the things are not really part of fuel, like 50% nitrogen and 0.1 of course oxygen and 8% CO2. But you again I must tell you that these constituents will be varying depending on the type of gasification units you are using, and also the whether you are using oxygen or you are using air. If you are using air, nitrogen will be more, and of course, the propane generally it contains large amount of propane and small amounts of other hydrocarbons. Biogas, it contains majority is methane, and of course, a lot of, therefore, the calorific value of biogas, propane and not propane, but the producer gas are quite low as compared to the natural gas or the LPG, that we will see little later on. So, heating values, if you look at amount of heat released per unit kg when it undergoes oxidation at normal pressure and temperature, we call it as a heating value, right, which is very important. Question arises, how will evaluate the heating value of the fuel? How will evaluate? What are the ways of doing that? Can anybody tell me? I want to know, let us say methane, what will be the calorific value? What we call heating value is nothing but also the calorific value of the fuel. That means, how I will go about it? If I will go for a liquid fuel, let us say kerosene, how will evaluate it? If I will go for a solid fuel, how I will evaluate? I need to know how to evaluate, find out what is the value. For example, you have come up with another exotic fuel, let us say for a propellant, for a rocket engine, you need to evaluate how much energy it will give.
We can change the heat energy into work or calculate from work we can calculate the heat.
Is it really so? Why not directly? Why I will convert into heat, heat into work, then it comes to the efficiency, then how I will evaluate efficiency perfectly. It is a very simple way, you just burn it and then find out how much it can heat being generated. per unit kg of fuel. There are two units are being used, one is known as bump calorimeter, you must be knowing, it is being taught to you, okay. That is meant for liquid and solid fuels. That means you can measure the heating value or the calorific value of solid and liquid fuel using bump calorimeter, whereas for gaseous fuel we cannot use it. We will have to use a Juncker calorimeters for measuring the calorific value of a gaseous fuel, and you can refer my book, it is given the schematic which I will not be showing here, and understand how it can be done. So, when you talk about this heating value, there will be two heating values, one is higher heating values, that value heating value of fuel when water is condensed. That means, whenever combustion will taking place, particularly the hydrocarbon and hydrogen, water will be formed. If it is condensed, then you will get that heating value which is known as higher heating value. There will be low heating value where the amount of heat released by burning 1 kg of fuel is and assuming the latent heat of vapor and the reaction product is not recovered. That means, we have it is not condensed, it is a part of it. So, that is we call it as a lower heating value. So, lower heating value is basically higher heating values minus m, that is the amount of water being formed per kg of fuel and the amount of fuel into delta Hv, whereas delta Hv is the heat of vaporization for water, which is taken at generally 298.15 Kelvin, and all with reference to the what you call these values, and we will discuss little bit as we go along how we will evaluate and other things, right, about the calorific value of a fuel. So, if you look at the types of liquid fuels, of course, we know this gasoline, it is nothing but your petrol, right, what we use, we are all familiar with that petrol price, also diesel price, there is a diesel price is going up, and this is the high speed diesel which are being used for like some places like kind of things. Generally the normal diesel is being used in automobiles, furnace oil is used in furnace, kerosene which is used for domestic purposes, also aircraft engines, gas turbine, ramjet engines, of course, I will be talking about it kinds of kerosenes, and alcohol which can be used in ICE engine. But beside this there are several fuels which are used in scramjet engines, liquid propellant rocket engines, ramjet engines, like those are hydrogen and UDMH, unsymmetric dimethyl hydrogen, and MMMH, liquid hydrogen, and triethyl amine. These are the all kinds of fuel which we will be discussing as you go along, and then liquid oxygen, red fuming, nitric acid, dinitro tetroxide, nitrogen tetroxide, and those things we will be discussing as you go along. So, if you look at these properties of the liquid fuel is very important. So, also the gaseous fuel, what I talked about the heating values for solid, liquid and fuel, but liquid fuel will be having certain properties which must be looked at carefully. And if you look at the specific gravity is one of property which all of you know, it is basically ratio of mass density of fuel to mass density of water at the same temperature, right. And there will be that means Ag, if I say the specific gravity, it is the density of the fuel divided by density of water at the same temperature. Generally the reference temperature is taken for the for both the fuel and water as 288.8 Kelvin, right. And this specific gravity is a very important aspects, because that will tell you about the volume contents and also the amount of reactions in the combustions and other thing. So, in order to have a scale, this American Petroleum Institute, they have come up with a scale which is empirical in nature, that is the API-SG is equal to 141.5 divided by SG minus 131.3. What it indicates? That means SG is a smaller, that means it is a lighter, right. If it is small, this is a lighter liquid fuel, and then this is the specific gravity, that is American Petroleum Institute scale, that will be higher, right. If it will go down, then this will go up, kind of things, and you can evaluate for various fuel kind of things. So, and as I told, this specific gravity can be connected to the heating value of the fuel, because the amount of molecules, and then what are the weight of that, which will be deciding. So, therefore, like it can be related this specific gravity, that is American Petroleum Institute scale specific gravity with the HEV. And for gasoline, if you look at this high heating value is equal to the low heating value 93 APISG, right, minus 10 is a kilojoule. If you look at these are basically what you call a empirical constant, what it is for gasoline they have used, and similarly for the kerosene it is having similar numbers, right. So, if you look at the density, which will be changing, because these are all petrochemicals, like density I can have a change, depending upon what I want, I can really play around, get these heating values as well, right. So, there is another important properties which we need to look at, that is the auto ignition temperature, the lowest temperature required to make the combustion self sustained without any external aid, because if you want to make a combustion self sustained, we should go a temperature beyond the auto ignition, so that it can be, otherwise we need to continuously giving the ignition energy, right. So, this is a very important parameters which need to be looked at, and it can also be used for the safety reason to avoid this kind of a explosion kind of thing. So, there is another very important point, that is the flash point, which is basically minimum temperature at which liquid fuel can produce sufficient vapor to form a flash or a flammable mixture with air, right. That means, what will happen? It will vaporize, as a result there will be a flash, and if like it will and then it will again discontinue, right. That means, it is a phenomena which will be remaining for certain time. So, it is very important from the storage point of view. In other words, this is this is the maximum temperature below which a liquid fuel can be stored without really what you call, without any fire hazard kind of things, right. So, therefore, this is very important aspect to qualify, to say that look, I will have to store this liquid fuel under set, otherwise it will be it can incur a fire which is hazardous in nature. So, the fire point, which indicates the minimum temperature at which liquid fuel produces sufficient vapor to form a flammable mixture with air, right, that continuously support combustion, establishing flame instead of just flashing. That means, it will ensure a continuous combustion, right. That means, when I am talking about the to sustain combustion, I should go beyond the fire point, right. And when I am talking about storage, I need to have a temperature at which I can store a fuel must be less than the fire flash point. So, there is a whenever you use hydrocarbon fuel, lot of soot will be formed because of incomplete combustion and everything, and liquid fuel is having prone to the soot formation. Therefore, we need to find out soot point, and which is a measure of tendency of liquid fuel to produce soot, because the soot is not really good for the gas turbine or any other applications. So, therefore, it must be also talked about when you are judging whether this fuel can be used for your engines or not. So, these are the properties which are very important. I must just tell you the specific gravity which I have shown for this kerosenes and ATF, aviation turbine fuel, JP8, there are several kinds of thing, you can look at the number, and the viscosity, kinematic viscosity shown here, and boiling point, if you look at it is having range, and flash point, if you look at this is the 311 and 325 which is nearby, And auto ignition temperature, if you look at it, is what you call higher than the flash point, and of course, the stoichiometric ratios is generally hydrocarbon fuel will be around 15 that. And the heating values, if you look at, all are similar numbers like 45.2 and 43.5, 43.5 megajoule per kg, right. And there are types of solid and fuel oxidizer. There are several kind of thing, biomass like wood and sawdust, all those things, lot of things are there. You need to use air oxidation, domestic purposes, even the engine can be run, coal, coke, charcoal, several kind of things. But the special fuels, particularly for the what you call rocket engines, is the nitrocellulose, STPB, CTPB, which we will be discussing little later on. And there is a several other oxidizer like nitroglycerin, which are solid in nature, keep in mind, ammonium perchlorate, ammonium nitrate, nitrogen tetroxide kind of thing, which is used in solid propellant rocket engine and hybrid rocket engine. I will just ask a question, is there any possibility that we can have a solid propellant fuel, or the fuel from the natural products, not like these chemicals? You please think about it, let us see. As we go along, I will give some clue about it. With this, I will stop over.